Hello, and welcome to this pre-recorded event for the June 2015 examination for Unit C2 GCSE Science, Chemistry. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. Here are the aims and objectives of today's session. You will receive feedback on national performance of candidates in Unit 2 of the June 2015 examination series. Consider the variation of candidates' performance on different questions and possible reasons why. Look at the examiner's report. Address common issues. The next 4 slides will look at question 3A Part 2 of the higher tier paper. You will find it useful to look at this question on page 8 of the question paper. You may wish to pause the video at this point to read the question. Many candidates answered this question well. All that was needed was lines representing the energy levels of the reactants and products, as this example shows. In this example, if the levels had not been labelled as reactants and products, then 1 mark would have been awarded. This candidate chose to use the names of the reactants and products. Again, this was awarded 2 marks. I just need to point out here that activation energy is not on this specification, and so is not expected to be included in such a diagram. Similarly, the line linking the reactants with the products to represent the change in progress of the reaction is also beyond this specification and not expected. This candidate has shown energy levels, with the left-hand side one being lower than the right-hand side. This would have attracted only 1 mark, but they have been labelled incorrectly, and so scored 0 marks. In this question, successful candidates understood what was required in the form of an energy level diagram, kept the labelling simple as reactants and products. The next 4 slides concern question 4A Part 4 of the higher tier paper. The 3 marking points here were for the mass of all the copper-63 atoms, that is, 63 times 70, the mass of all the copper-65 atoms, that is, 65 times 30, and the 3rd marking point was for the total mass of all the atoms divided by 100 to give the answer 63.6 as the relative atomic mass of copper. This answer is not as straightforward as on the last slide. Here the candidate has calculated 70% of 63 to give 49.1, and 30% of 65 to give 19.5. Then added these 2 numbers together to give the final answer of 63.6 to score all 3 marks. It is clear that this candidate was unsure as to how to tackle this question. The candidate knew that the mass of the isotope had to be multiplied by its percentage, as can be seen for both isotopes. But the candidate then made the error of dividing the total mass of the copper-63 atoms by the total mass of the copper-65 atoms. Only 2 marks could be awarded here. In this question, successful candidates set out the calculation in a logical manner, understood that the relative atomic mass would be obtained by finding the average mass of all the copper atoms present in a sample of copper. Look at this example of an answer to question 4A, Part 4, on the higher tier paper. Using the mark scheme, decide what mark you think should be awarded and why. This is a point at which you can pause the video to look at the mark scheme and decide on the mark and why. The first mark was for dividing the mass of each element by its relative atomic mass. The second mark was for the whole number ratio obtained from the previous step. The third mark was for the formula of phosphorus bromide based on the whole number ratio. Successful candidates set out their calculations in a clear logical sequence, divided the mass of the element by its relative atomic mass, calculated a whole number ratio, wrote a formula based on the whole number ratio, realized that the atoms would be in a simple ratio. On this question, less successful candidates divided the mass of the element by the wrong relative atomic mass, made an error in calculating a whole number ratio, left the final answer as a ratio and not as a formula, made assumptions about the formula initially and tried to work towards them, set out any working in a random way. The next 4 slides are about the dot and cross diagram in question 2E of the foundation tier paper. Take a moment to read the question on page 7 of the question paper. You may wish to pause the video at this point to read the question. Many candidates performed well on this question, which is one of the simplest dot and cross diagrams that candidates are expected to know. Here it looks like the candidate realized that the dot and cross diagram would involve the 7 electrons of the third shell of chlorine and the 1 electron of hydrogen. Unfortunately, this candidate put all these electrons together, as shown together with a charge on the outside of the bracket. The marking points for this diagram were 1 mark for the correct electron pair between the chlorine atom and the hydrogen atom, 1 mark for the remainder of electrons around the chlorine atom. So, this candidate did not score any marks with this response. At first sight, the candidate has appeared to have drawn a good dot and cross diagram, showing a clear shared pair of electrons between 2 atoms for the first mark. Unfortunately, the candidate has shown too many electrons on the outer shell of the chlorine, an extra 8 in addition to the shared pair, and so did not score the second mark. A clear dot and cross diagram showing a shared pair of electrons between the hydrogen and the chlorine atom, with the correct number of electrons around the chlorine atom. In this type of question, we do not penalize the use of incorrect atomic symbols. Here, the candidate gave the atomic symbol of chlorine as lowercase c, lowercase l. In addition, we do not penalize if electrons are all shown as dots or all crosses as crosses. Unsuccessful candidates did not check to see if they had the correct number of electrons around the chlorine atom. did not set out the diagram in a logical manner. The next 4 slides are about the purification of an insoluble compound in question 4C of the foundation paper. Just 1 mark was awarded for this answer. Filtering the precipitate from the mixture was the first marking point. But this candidate did not purify the barium sulfate. In this purification process, candidates should be taught the simple sequence of filter, wash, dry as the 3 steps involved. This candidate appeared not to understand the question, as the answer did not contain any indication of how the barium sulfate would be purified and dried. This is a very good answer, with the 3 steps involved clearly laid out in a logical manner. At this level, a 3-mark answer is not that common. Unsuccessful candidates are often confused about the steps needed, will often miss out 1 or 2 steps of the process, will often try to introduce other steps into the process. Look at this answer for question 3D of the foundation paper. Using the mark scheme, decide what mark you think should be awarded and why. This is a point at which you can pause the video to look at the mark scheme and decide on the mark and why. The marking points here were for the transfer of electrons, shown by magnesium losing electrons and oxygen gaining electrons. Correct direction of transfer as already indicated. The 3rd mark was for 2 electrons being transferred. This answer scored all 3 marks. On this question, successful candidates stated that electrons were transferred, gave the transfer as from magnesium to oxygen, gave the correct number of electrons transferred. On this question, unsuccessful candidates often stated that electrons are shared, sometimes had the wrong direction of electron transfer, gave an incorrect number of electrons, or did not state the number of electrons being transferred. In order to improve their performance, candidates should learn the meanings of the terms atoms, ions, and molecules, and use the correct word in answers. Show all working for calculations. Read the questions carefully and use the information given. Give more detail in questions that require an explanation. Learn the meaning of the 4-state symbols and use them when writing equations. Practice drawing dot and cross diagrams. Learn how to write the formulae of ionic compounds when given the symbols of the individual ions. Here are some useful links for examination statistics and grade boundaries. We have just published our specifications on the Edexcel website. They have been published early in draft form to enable teachers to have early sight of our proposed approach. We are also running a series of launch events. Our draft specifications and sample assessment material, as well as further information about our launch events, can be found on edexcel.com. Thank you for taking part in this event. You will soon receive an email directing you to an online feedback form. The form takes no more than a couple of minutes to complete. Please let us know your thoughts by filling in this short form.